In this video, the following concepts are studied. Unit of surface, unit of volume, characteristics of the unit, base quantity, derived quantities, unit of length, time, mass.
Sometimes some people do not have a good idea of the unit of surface and the unit of volume. That's why we explain them. The unit of area is a square meter, that means a square whose side is equal to 1 meter. Imagine a surface. We want to calculate its area. We have to cover that surface with the help of that square. We see that the total area is 2.5 square meters. Similarly, the unit of volume is cubic meters. That is, a cube whose all sides are equal to 1 meter. To properly understand volume, it is better to imagine that the inside of an object is empty. We have to put the cubic meter in it. You can see that the volume of the object is equal to 12 cubic meters.
Unit and its characteristics. 1. Must be fixed and do not change. For example, a spring cannot be used as a unit of length. 2. Be available, so that everyone can use it and be able to copy it. 3. It can be determined with great accuracy, to be able to design accurate experiments. Therefore, if we use it in any place and at any time and with any accuracy, we will get the same results. For example, the human span is available everywhere but is not fixed, because it varies from person to person.
A question arises here. There are many quantities in science. Should a separate unit be defined for all of them? The answer is no. All of them can be expressed in terms of 7 quantities. These 7 quantities, selected by international agreement, are called the base quantity, and the unit corresponding to them is called the base unit. These quantities are independent. That is, they are not dependent on other quantities. Not been defined in terms of other quantities. We first explain the table of these quantities. Then we express the derived quantities.
The first column of this table shows the base quantity. Includes length, mass, time, electric current, thermodynamic temperature, amount of substance, luminous intensity. The second column shows the quantity symbol, L, M, T, I, T, N, IV. The third column shows the base unit, meter, kilogram, second, ampere, Kelvin, mole, candela. And the fourth column expresses the symbol of the base unit, M, kg, S, A, K, mole, CD. In the field of mechanics, the first 3 lines are used a lot. We will explain the rest of the quantities in other topics.
For example, suppose we measured an object length. We say, the length of the object is 5 meters. And we write, L equals 5m. Here L means base quantity. 5 is the value of the quantity and m means base unit. Similarly, instead of writing the duration of an event is 5 seconds, we write, t equals 5s. and m equals 5 kilograms means that the mass of the body is equal to 5 kilograms. The important thing is, this quantity is the same everywhere in the world. This means that it does not matter if the object is in the United States, Canada, or France, it should be the same everywhere.
Now we express the other quantities. The rest of the quantities are called derived quantities. The unit corresponding to these quantities is called the derived unit. The derived quantity is not independent, that is, it depends on the base quantities and is defined in terms of the base quantity. For example, in the kinematics section, we show that the velocity of an object is calculated by this formula. Meter is units of length, and seconds is unit of time. So the unit for speed of an object is meter per second.
As mentioned earlier, 3 of the 7 major quantities have more applications in mechanics. That is, length, time and mass. Here we explain these 3 quantities. Unit of length. In 1792, scientists defined 1/10,000,000th of the distance from the North Pole to the equator as 1 unit of length. That means 1 meter. This definition was later dropped for practical reasons. And the distance between 2 engraved lines near the 2 ends of a platinum-iridium bar was defined. This bar is held at the International Bureau of Weights and Measures, near Paris. In 1960, the unit of length was defined in terms of the wavelength of orange-red light emitted from krypton-86 atoms. In 1983, the unit of length was defined in terms of the distance that light traveled over a period of time. However, accurate samples of the standard unit were made and sent to all countries. In this way, the various measurements in the countries of the world were perfectly coordinated. And standardization happened.
Unit of time. Consider 2 basic concepts of time: moment of time, and duration. These 2 concepts are different and should not be confused. When we say a person starts moving from city A at 10 o'clock and reaches city B at 11 o'clock. 10 o'clock is the beginning of the movement, 11 o'clock is the moment of the end of the movement, and 11 to 10 is 1 equals the duration of the movement. Here we define the unit of time. Any phenomenon that is repeated regularly can measure time. For example, moving a pendulum, or moving an object attached to the spring. We know that a complete rotation of the Earth around Sun is equal to 1 year. And the time of complete rotation of the Moon around the Earth is equal to 1 month. The time of complete rotation of the Earth around itself is equal to 1 day.
All of these movements have been used to measure time since ancient times. In order to measure time, we need to define the unit of time. If we define the unit of time based on the length of the day, 1 second is equal to this fraction of the day. In fact, a day is 24 hours. 1 hour is 60 minutes. 1 minute is 60 seconds. So a day is equal to 86,400 seconds. In 1960, seconds were defined in terms of the length of the equatorial orbit. In 1967, at the 13th General Conference on Weights and Measures, seconds were defined in terms of the cesium atomic clock.
Mass. Although mass is related to the amount of matter, it is defined as follows. The mass of matter is the resistance of an object to change in velocity. We will study this concept and the concept of force later. Galileo used the word massa, but Newton used it scientifically. Body mass depends on two factors. One is the number of particles that make up the body and the other is the type of each particle. The mass of an object can be measured with different scales.
Do not confuse mass and weight. The mass of matter is constant everywhere. But the weight of an object is the force exerted on the body by the earth. Therefore, the weight of the object is not the same in different places. For example, suppose a body mass on Earth is 6 kilograms, then it weighs about 60 newtons. The mass of the same object on the surface of the Moon is the same as 6 kilograms. But it weighs 10 newtons. We will explain these concepts further after we state Newton's laws. There we will see that there is a direct relationship between mass and force of weight.
The unit of mass in the SI system is the mass of a cylinder made of platinum and iridium. This cylinder is kept in France. By international agreement, its mass is defined as 1 kilogram. In a more precise definition, the unit of mass is defined as 1/12 of the mass of carbon-12 atoms. This unit is rarely used in mechanics, so we will study it later.